can see my name is Chimakalu, and our our fa- facilitator for today is no other person than engineer Kunle Olorukoya. Okay, so before we proceed, we are going to be entertaining questions. Questions. So if you have any questions, you can please drop at the message box. Maybe after the learning session, we attend to your questions. So overview about Genex Technologies. We are into sales and distribution of solar products. And we are also into residential and commercial and industrial solutions. Recently, we just carried out NIM, yes, 100 kV system at NIMR, which is a long-lasting solution to them. And that's not all. We also have Genex Solar Academy, where we train people how to become an engineer or how to how to rule their world in solar system. Okay, so so let's sit tight as we listen to our honorable engineer. So engineer K, the floor is yours. You can take charge. Thank you, sir.
Good morning, everybody. You are welcome on board Genex Technologies. Now, the topic, as stated, is understanding all-in-one ESS system. Today, let's go straight to the overview of all-in-one energy storage system. It is an integrated unit that combines all the major components needed for a solar power and battery backup system into one system. Instead of purchasing and installing separate devices, then you just have the system comes prepared, pre-engineered to work together in just one package. The key advantages. When we look at the listed advantages, you see the first one is simplified installation. It makes the installation simple, so fewer separate components and lesser wiring, reduced installation time and complexity. Because it's just one unit, just carry once you position it, that's all. Just like a unit fridge or freezer. Then your solar cable will just come from outside, terminate to it. Your load cable terminates to it. Your utility connects to it. The battery is already fixed with it. So all other management of all this, your load, battery, and everything is within the system itself. So it makes it very compatible. You don't need to be drilling a lot on the wall. You don't need much activities to install it. So saves time. Just put it on the floor. It comes with breaker, comes with other things that makes it very simpler to install. And then we now look at saving space. So space saving design. When you put only one, and then when you want to increase the battery, you put it on top, or because one is there, it's the only one standing to give you the energy. So it makes everything look neat. So the space is conserved for people. Many people want to maximize the usage of the spaces they have in their environment. The next one now, among the advantages is neater appearance. It looks so neat. It's just one unit. Then even if you are increasing the battery or anything, it still looks so neat because it's the same brand, it's the same model. The battery is of the same color, not that they will be color rioting. One is red and then the other one is black, or the other one, they are not fitting. No, since it is all in one, all parts, features, everything works together to make it look neat. Then is a single enclosure, creates a cleaner and more organized installation. Now let's look at the optimized performance. Components are designed and tested to work together effectively, efficiently, because it's all in one. You are not bothered with the problem of I don't know whether what's the code for communication between the battery and everything. It manages everything perfectly. It knows when to communicate with the battery. Everything is just connected together. The charging current, the load current, everything is managed by the system. So you are less bothered. Even configuration, is less. You won't bother yourself that, okay, I need to check what is the manufacturer of the battery saying about the specifications, the parameters, and all that. No, you don't need to bother yourself. Just check what's the capacity of my load. The grid is okay. The solar voltage is okay. Then you connect all to it and manages everything well. Then how to evaluate an all-in-one system? How do you evaluate it? Now, look at the capacity and sizing. Matching system to household/business energy needs. Here you need to know what is the capacity of load you need, which will determine the size of the all-in-one you need. It will determine the size of the capacity of the battery as well. If you need a longer backup time, then you need a bigger storage, which is the battery. So all these must come together. Your load, the time you want, then your space for solar panel. So how many panels are you going to use at the end of the day? Because the all-in-ones, they are high voltage systems, so they accommodate a wider variation of capacity of solar panels, which is a lot more added advantage. So if you have if 5 is close to the minimum and you are using 5 panels and you say, okay, tomorrow you want to increase, just add some panels to it and then you increase without incurring a huge amount of money because you want to do an upgrade in solar, in terms of the solar panels. So it's important to factor that in. Then the next one is battery chemistry and lifespan, which has to do with the life cycle of the battery. It is always good to get your system from the right source, from a trusted source, so that you won't be thinking, is it the battery? Why is it giving me a lesser backup time? Or is the battery capacity enough? What type of battery are they using? Get it from the right source. It's very important. So if the battery capacity is enough, the battery components, the chemistry is right, the capacity will be complete. We cannot give you 10 kilowatt hour and then we test the capacity is not up to 10 kilowatt hour. No. So that at this part of it, we need to be careful. This is one way to evaluate an all-in-one system. The next one is inverter efficiency and surge capacity, which has been designed with the system. The inverter is efficient. They've factored in everything with the overload protection, over voltage, under voltage. Everything is part of the function of this system. So when the battery is going low, it manages it properly. So all these are part of the system, and inverter efficiency and surge capacity is we need to know what's the surge of the capacity of the load that we want to put. Is it an AC? Are they just small fans, lightings that will not introduce surge? Because if you don't know that, then you may be choosing the wrong capacity of the all-in-one. And then one will now complain that, oh, it's not performing as I want. But if you determine all those ones that will make your system to work perfectly, then you don't have any problem. Then expandability. The system can be expandable. You can add to them. You can increase the battery. You can connect some in parallel. You can connect some to achieve three-phase synchronous output. So all these are features that are in the system. So it now depends on what you want that will determine which one you are choosing. If yours is to power a three-phase appliance that must work on a three-phase supply, then you are good to go. You are covered. Choose the one that is parallel. The one that is parallel, definitely there is a way to connect it to give you that, which is in the user manual. Once you get the system parallel together, connected, cascaded, then you get your results. Then brand reputation, like I mentioned, it's very important. Warranty terms and after sales support matters in whatever you are doing on this, not only on all-in-one, but on all our products. On any product you want to buy, is very important. You look at the brand reputation, you look at the warranty terms, and after sales support. Now we have RSP, solar generator, an all-in-one system. You can see the capacity. We have 1.2 kilowatt plus 4 kilowatt hour battery, 3.6 kilowatts plus 8 kilowatt hour battery. Please note this. 1.2 kilowatts is the capacity of the inverter. That's the capacity of load the inverter can carry, can power. While the 4 kilowatt hour is the capacity of the battery. Now, I know that some people are still making some mistakes in terms of this. They will say 1.2 kilowatts. They want to make it look like it is the same thing as 4 kilowatts. No, somebody may come up here and say, okay, yeah, 1.2 kilowatts capacity of inverter, then 4 kilowatts capacity of this. That means capacity of battery is bigger than the capacity of inverter. It's not like that. That's why battery is rated in kilowatt hour. Is a storage. It's talking about the time, the capacity of load it can power, and the time it can power the load, the duration. So they are not exactly the same thing, like in generator or any other source of supply. So The third one here on the arrangement here is 6 kilowatts, which is the inverter that, as you can see on top, while the battery is 10 kilowatt hours. The next one is 11 kilowatts, while the battery capacity, the unit battery capacity is 16 kilowatt hour. So if you want to cascade, that means you will need to add a 16 kilowatt hour battery to it. It's not all of them. It is not all these systems are expandable in terms of battery or parallelable and all, but we'll let you know. Like the 1.2 with 4 kilowatt hour, it's not parallelable. But for the last one I just mentioned now, which is the 11 kilowatt, it's parallelable. And you can also increase the battery capacity.
Hello.
So let's see further. RPS 5 kilowatt slash 5 to 15 kilowatt hour stacked all-in-one system. Now, the inverter is 5 kilowatts, while the battery is 5 kilowatt hour. That is, each battery is 5 kilowatt hour. So you can cascade, you can increase the battery capacity to 15 kilowatt hour. You don't need cable, you don't need anything extra than to bring the battery, remove the inverter, put the battery on top of the one you have before, put the inverter back on it, still the same stand, the same spot. The only thing you notice is the height has increased. Then if you have added one battery, you feel, oh, I need to add another battery to it, you do the same thing. Remove the inverter on top, put the next battery on top of those that are there. Automatically, they are wired, they are connected together, and they will be properly managed by the system because that's the way it was designed. So now, if you have 3 batteries of 5 kilowatt hour, then you have 15 kilowatt hour battery connected to the single inverter that is there. The next one is ESS 510, which is 5 kilowatt, and the battery is 5 kilowatt hour. It's also all-in-one system. So you can increase the battery as in the picture. You can work with one battery. Then when you want to increase the battery, just the way I explained the other one, just pull up the inverter, put the next battery on top, still on the same spot. You are not occupying additional space. It's still the same spot. It's just the height that is increasing. So you have increased it, then you have additional storage. Okay, now RSP. (1.2 kilowatts), while the battery is 4 kilowatt hour solar generator. So going through the specification, you can see the details as we have it down here. We look at the capacity. Just a moment. Okay, the rated output voltage. In most cases, they come with 230 volts, which is standard, which you can find in most inverters out there. But the input range is now from the input utility supply, that's the one that they put voltage range. You can see it's starting from 170 volts to 264. We all know that 264 volts is even high, but that's what it can withstand without getting damaged. You know, and it has the UPS function, and it has the home appliance function. So it depends on the one you want to choose for your appliance. So it can tolerate a wide range of frequency, and it's auto sensing. Once the frequency is changing, it's following it up. It's not that it just sense that, oh, the frequency has reduced slightly from 50 Hz and then it will shut down. No, you can see it can operate from 40 Hz to 70 Hz, which is quite wide. So then you look at AC charging current, up to 60 amps. Then look at the maximum input current, which is 10 amps. All these are part of the rating. Then the next one, you look at PV, which is crucial. The solar charging type, MPPT. If you see any of this kind of products and the charge controller is not MPPT, please be careful. I will even say run, because you know what other charge controllers that are not sensitive and active like MPPT will do. So then you look at the PV maximum input power for this 5 kVA. For this capacity, which is 1.2 kilowatts, you can see the solar capacity is 1000 watts. Then the tracking, MPPT tracking voltage range, that's 20 to 100 volts. So which means if your solar panel is just about maybe 30 volts or 40, it will work and deliver the power, the required power. So then look at the maximum PV input to the MPPT is 125, which I don't advise anybody to operate, because that's the maximum. You know, if you are operating at that region or range, then if anything happens and your voltage has to spike up, then you can get it damaged if it goes beyond it. It is stated clearly that's the maximum you can take. There are many protections in the system, but then we have to be careful in terms of our operating range. Now, PV maximum input current, that's 14 amps. So it can handle that voltage at 14 amps. And then PV charging current range, this is the one that goes into the battery. The 14 amps is the current of the solar panels direct. There are two things. We don't need to mix them up. 14 amps is the maximum current that can flow through the solar cable into the charge controller. That's the maximum it can accept from this. If it's more than that, it's not going to take it. It will only take 14. But then, the one that will now go to the battery is 60 amps max. So then look at other part of it. The output voltage is between 220 and 230. Like I said, it's always by standard set to 230. Then frequency is 50 Hz. But the peak power of the inverter itself is 2,400 watts. That peak power is referring to the surge handling capacity, because the power of the inverter is just 1.2 kilowatts. So the battery energy, which is 4 kilowatts, this is 4.02 kilowatt hour. That's the capacity of the battery. which is lithium ion, as we know. Battery voltage is 12 volts, which is 12.8 volts. Cell technology is like PO4, which is a very good technology in terms of lithium ion batteries. So it's a very good technology that gives you rest of mind and the expected backup time all the time within its lifespan. So you can see the fully charged voltage of the battery is 14.6 volts, while the fully discharged voltage is 10.4. All this, the inverter will manage by itself. Then display is having LED and LCD. The LCD shows in numbers the output voltage, input voltage, battery voltage, solar voltage, everything. You can see all this on the screen. So then looking at the storage environment, it's talking about 15 to 60 degrees centigrade. So this is and the specification, the size is stated in the product dimension below, which is the physical side. So the next one is RPS 3.6 kilowatts. That's the inverter, while the battery capacity is 8 kilowatt hour, and it's also all-in-one system. So we also have its own specifications below, which I will quickly rush through. The voltage constantly for all of them across board is 230. And the voltage range, like I mentioned, is the same thing. What's different in them is the capacity. So we have the PV input, which is MPPT, but the PV capacity of this one is 4,000 watts. That's the PV input. The MPPT tracking voltage is from 40 to 450 volts. You can see this is a higher voltage, which gives room for a lot of solar panels. Then the maximum MPPT tracking, the maximum PV input voltage is 500 volts. For the PV charging current, range is from 2 amps to 100 amps. And what they mean by that is the current that goes into the battery. That's the current that goes into the battery. Because anytime you see charging currents and you see the range very high like that, like 100 amps, 80 amps, like it's talking about the current that's going into the battery. Then maximum charging current is 100. That's why the range was from 2 to 100 amps. You know, it's lithium ion. It varies based on demand and the communication between the battery and the inverter itself. So then we have output, rated output power, which is 3.6 kilowatts. Output frequency, as usual, is 50 Hz. Battery energy is 8 kilowatts, which is 8.04 kilowatt hour. Battery voltage 25.6 VDC, which is different from the first one that was 12 volts. This is just about 24 volts. The first one was 12 volts. That's why we saw 14 volts, 14 point something maximum of fully charged. But this one now is double the battery voltage, which is 24 volts. It's also the same technology at PO4. And then fully charged voltage is 29.9 volts. And then fully discharged is 20.8 volts DC. So DOD is 80%. Now, the product's design lifespan, which is in cycle, is 8,000 cycles. That's for the battery. So communication interface can communicate through Bluetooth. So you can check the battery through Bluetooth and Wi-Fi as well. So then the display, you can see LED and LCD. You always have the two. The LEDs may just be like 3, just to indicate maybe there's a fault, to show red. When it's showing green, it has its own meaning. If the battery is full, there's a way to show green. But you see other clearer detail in numbers in the LCD. So I think that will be all on this. Then you can see the physical dimension below. The next one is 6 kilowatts inverter with 10 kilowatt hour battery, all-in-one system. I'll go straight to the maximum input current, which is 27 amps. That's input current, that's the grid. Then PV inputs, it's also MPPT, 9,000 watts. The inverter itself is 6,000 watts, but the solar capacity is 9,000 watts. This gives a room for battery to charge while you power your pre-selected loads. It depends on the usage. So PV charging current is also from 2 to 100, but maximum charging current is 120 amps. So which means if you are using utility plus the solar panels, then the batteries can charge faster at that rate of 120 amps. Then the output capacity of the inverter is 6 kilowatts. The voltage is by default set to 230. And if you want to bring it down to 220 for a reason, you can do that. You can set it up to 240 if you want. The frequency is 50 Hz. Because we know that some loads operate on 60 Hz. So that's why it's flexible. You can change it to 60 Hz if you want, depending on the type of load you are powering. But generally acceptable frequency here is 50 Hz. So you can look at the peak power, which is the surge, which is double the capacity, is 12,000 watts. That's the surge it can handle. So going straight to maximum main output power, that's 6,000 watts. Then go to the battery. Battery is 10.5 kilowatt hour. Battery voltage is 51.2 volts. We'll see in this one, as the capacity of the inverter is increasing, then the battery voltage is also increasing to that voltage level, which is 48 volts normally for this type of battery that has 51.2 volts. Then the technology is the same, which is reliable. Then fully discharged voltage is 41.6, while fully charged is 58.4 volt. You know, this system, you don't, like I mentioned before now, you don't need to bother yourself about you want to set this value. It's communicating, so it's managing itself. It knows when the battery is fully charged, it knows when to disconnect, it knows when to pump higher current, it knows all that. Then the display is also LED and LCD. Then the communication channel is Bluetooth, which is optional. Bluetooth and Wi-Fi, because you can also monitor whatever is going on remotely. Now, you can see the temperature of the storage, which is important when we are looking at where to keep our system. It should be in a cool environment. Now, let's look at RPS 11 kilowatts by 16 kilowatt hour all-in-one battery. The output voltage is the same, all other things are the same, but the charging capacity in terms of solar, because you can see the MPPT capacity is 5,500 watts times 2. So it's having 2 inputs, 2 MPPT tracker. So you can connect 2 lines of solar panels to it to be able to get more energy. So it's also high voltage in terms of the solar, 60 to 500 volts. Then the PV charging current is also from 2 volts, but this time on this, you can operate up to 160 amps, which is the maximum charging current of the system. So then going to the other part of it, peak power of the inverter is 11,000 watts times 2. That peak power, like I mentioned, is referring to the surge capacity. It's always times 2 the capacity of the inverter. Capacity of the inverter is 11 kilowatts, while the surge handling capacity is the 11 kilowatts times 2. So going straight to the battery, 16.08 kilowatt hour is the capacity of the battery. And then it's a 48 volt system because the battery voltage is 51.2 volts. And you can see the low battery cutoff, the battery full voltage. And then looking at the design cycle, this is 8,000. The cycle is 8,000. So then you can see the physical size below. Go straight to RSP 5 kilowatt. 5 kilowatts slash 5 kilowatt hour to 15 kilowatt hour stacked all in one. The voltage of the inverter remains the same, just like that's the general function. Okay, you can see the AC charging current is 100 amps. While the maximum charging current, maximum input current is 130 amps. Okay, so we have different categories up there. We have the 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 three the 3+3. This is 3+3 RSP, RPS 3+3, and then we have 5+5. So those are the value. Those are the ones that are available. Where it should now be 5+10, which is 5.5, where the battery capacity will be 10 kWh. The specifications will be shared. We have details of all these because we can see the voltage is always the same when it comes to the output voltage, input voltage, and all. So the only part where you need to be more conscious is the solar capacity and the capacity of the system itself. The MPPT capacity for this one, we can see the MPPT. So let's go to the next slide. Well, the specification of all these will be shared. Well, the bottom line is that why we go into the specification is for us to know those parts that you need to be more conscious of. Get every details required, get the specification, do everything before you go for the main unit, so that you don't get it and now look, oh, I'm supposed to have gone for this. Although they are friendly, they are stackable, if you get lesser, you can always increase. But then you should know what size you want to go for first. You may not be looking at 15 kilowatt system, and then the first one to get is 3 kilowatt. No. So we have to be conscious of all this. So we go to the next one, ESSA 510, which is 5 kilowatt, and the battery is 5 kilowatt hour, all in one system. So as you can see, the voltage is also the same in terms of the output voltage, but we go straight to the solar charger and AC charger. The solar charger is MPPT. Maximum PV rate is 5,000 watts. The inverter capacity is 5,000 watts. The battery is 5,000 watt. 5,000 kilowatt, but you can increase it, can cascade it. That's what it means. So the input voltage for the MPPT is 500 max, 500 VDC max, but the operating range is 120 to 450 volts. You can put all together in series, not exceeding the given value, then you get your power delivered. So the charging current AC charging current is 100 amps. Maximum charging current is 100 amps. So you cannot charge more than that. Maximum solar charge current is also 100 amps. So it doesn't deliver. It also manages everything within itself. Now let's go to the nominal voltage, which is, that's the battery now, which is 50. Two volts. So you can see the low battery disconnect points. All these will be managed by the battery, by the inverter itself. So then there is breaker as protection on the body, which we have the BMS breaker. Then the maximum charging current is 20 amps. That is on the solar cable. That's the current that will be on the, we mentioned the charging current which is going to the battery is the one mentioned as 100 amps. I'm just re-emphasizing on this so that we don't mix them up, because I've heard people when they say the charging current is just 20 amps. So 20 amps is the one on the solar, while the maximum charging current is 50 amps at a certain temperature. The system monitors the temperature and knows when to increase the current because they communicate. So then the parameters, we can see the physical dimension below.
Okay. Thank you, Engineer K, for this for the wonderful learning session. So at this point in time now, we are going to be starting our live demonstration. So I've seen some questions, but we are going to attend to them after the live demonstration, so we can see the system we are talking about. Thank you.
Okay, you're welcome to the live demonstration part of the program. As you can see, this is the 11 kilowatts all-in-one. The battery is the one below it, and while the inverter is the one on top. So it's connected to a cable just to show that it's live, really.
Engineer Kule, we can't see anything.
Engineer Kule, we don't have visuals. We don't have visuals. We can't see from our end.
Hello, can you hear me, please?
Yes,
Then
we can hear you. We can hear
okay,
you,
please,
but we can't see the system.
Okay.
We can't see
Oh,
the
okay,
system.
okay. So, sorry about that. Just give us some minutes that would be rectified. Thank you. Who worked this? Okay, while we are waiting for the other part, let's go ahead on the question and answer.
Okay. So I think the first question here says, what is the minimum and maximum capacity available for this all-in-one? All-in-one, yes. Let me say it again. What is the minimum and maximum capacity available for this all-in-one?
Okay, thank you for that question. Yeah, the data sheet has been shared and it shows clearly the capacities that are available for different for each capacity we see the available sizes are displayed in the specification sheet with the ratings accordingly.
Okay, Engineer K, thank you for the answer. So the next question here says, do we also need extra air condition for it, or it has its own inbuilt air condition?
Okay, thank you. It doesn't need any extra or special air conditioner, but the system should just be positioned in a cool environment, not in a place that is hot. Then you know that this place is hot, it's completely enclosed, and then because when they work, they generate heat. They come with inbuilt fan cooling system that will work with them. But then, if they are also enclosed in an environment that is hot, it's not good. But on their own, just put them in a cool environment, they are good to go. They operate fine without any need for special fan or air conditioner.
Okay, thank you, sir. So the next question here says, how many can be parallel together? How many can be parallel together?
Like I mentioned, it's not all of them that are parallelable, but for 11 kilowatt hour, 11 kilowatt system can parallel up to 6 units. And you know, each one already has its battery with it. So you can put 6 together to work as a single phase system. You can put 6 together to work as a 3-phase system, whereby you have 2 on each phase. When you configure it like a 3-phase synchronous system, you can put 1, you can use 2, you can use 3, depending on your application. Even if it's 3-phase you want to get, you can still put 2 on a phase and then one on the other phase, depending on the load on that phase, and then it will still work as a 3-phase synchronous system. So it's flexible, and each standing unit has the capacity, capability of battery increase. You can increase the storage of each of them. Like one standing, you can increase the battery system by adding another battery to it. So if that's what you want to do for all that you parallel, good. To increase the storage, that is part of what you can do. But you cannot parallel more than 6. Thank you.
Okay, thank you, sir. So the next question here says, are the batteries available separately to buy? Okay, so we can scale up gradually over time.
Yes, which is the essence of saying, okay, you can cascade, not just for starters alone. If you want to say, okay, let me buy one with the battery the way it comes, okay, then maybe the next few months, maybe 1 month or thereabouts, then I want to increase, then you are good to go. So that's the advantage. You can increase maybe next week and say, okay, the upper week, now I want to add another battery to it. You can add another battery to it. So you can always you can parallel at any time. That's the advantage of the lithium ion, which you cannot be doing with other batteries, batteries that are not lithium ion, that because of aging and all that. If you buy a set of batteries today and you connect your system to it, then if it's not lithium ion that can accommodate all this charging, communication, and to really monitor the cells well, then if you go, if you increase such storage, is going to be a problem. But for this one, you can cascade conveniently without any fear of anything. Thank you.
Okay, thank you, sir. So this will be the last question before our live demonstration. So the question says, what is the factory configured DOD for the SVC ESS, and is the DOD configurable?
The DOD is part of the function of the system because it's all in one. It manages it. But if you still don't want it to get to where that point where it's going to drain the battery before it shuts down, the inverter itself is programmable. There are settings on the inverter. You can set, oh, this is where I want it to stop, and then it stops there.
Okay, thank you, sir, for
Hello,
the
moderator.
answer.
Some of us have our hand raised.
Okay, I'm seeing it. But after our live demonstration, we are going to attend to all the questions. For now, we're about to commence the live demonstration. So just sit
All
tight
right,
and
all right.
watch.
Because we
Thank
want
you.
to ask
Appreciate, sir.
a direct question, not
Okay,
via
okay,
chat.
no problem.
Not via
No
chat.
problem, sir. No problem, sir. Thank you.
Okay, you are welcome back to the live demonstration. As you can see, the system arranged. This is the 11 kilowatt with each battery. It's also powered, so you can see the display shows all you need. Shows the solar panel, shows whatever is happening in the system, you can see, and you can as well monitor remotely. So you have all the buttons to do your parameter settings physically. Then it's having it's on roller, so it's easy to move, but you can lock the legs so that it doesn't roll easily. but you can see the terminals as they are equipped with the system. So that makes it easy and easy for connection, easy for installation. They are already there. Just put your screwdriver, connect your cables to it. It's well labeled. You have input, you have output, you have everything, and it's having the breaker. So for protection as well. So the battery terminals are protected. You can see covered with the plastic. So you can extend to the additional battery you want to use as increased storage from here. You connect and you connect to the other battery. So communication, everything within this unit is done and is communicating with the battery properly. So you can see cable connected to it and it's connected to this. Then power on. It's already powered. Okay. So this is it. You can see how slim, looking fine as a single unit. If you want to put batteries beside it, that will be a separate thing. It will just stand beside it. Any increase you are doing will stand beside it. So that's the way this is done. And you can cascade, just like I mentioned in that answer given to somebody. You can connect this to another one, another size of it, to increase your the capacity to maybe 22 kilowatts, or you want to use 3, or you want this one now, 3 of it, just with the battery set that are there, you want to use it to power a 3-phase system, you are good to go. And if the capacity of the 3-phase system is high, you know, and you need a bigger storage, you can increase each of the units standing by increasing their battery, which is okay, and it's a smart way to make everything look neat. Very reliable. So that's that on this. Kilowatt. This is the 6 kilowatt, although this is not powered now, but it's the same way the bigger one displays. That's the same way it looks. So that's this. And you have the next one. You see that the capacity, as the capacity reduces, the size too and the space they occupy also reduces. Because the size of storage reduces, the physical size also reduces. They are not the same thing. So this is the smaller one, but all of them are on roller. All these 3 are on roller. You can see moving easily, and you can lock the legs when you finally position them to where they will stay. So they all have the terminal at the sides where you connect, and this is the power button. Somebody was asking for cooling system. You can see the fan for cooling. You have power button for the battery. So this is well equipped and user friendly. Then you can see the 1.2 kilowatts with the 4 kilowatt hour battery. This is the inverter. This is the battery. The terminal is also protected at the side. Okay. So you can see the way the interface is. It's having its sockets, the outlets on top with USB. You can see the USB ports, Type C. You can charge your phone. You can do many things with it. Then you can plug different loads. This looks like a plug and play system. It's having its input cable that you just plug to the wall, and then you plug to the inlet ports. Okay, the inlet port is here, plug the input cable this way, and then this one goes to the wall. That way, you have connected it to the utility supply. Then the solar input is also there, which is at this side. The terminal is there, so that's where you connect the solar panels cables to. With that, it's fully equipped and fully connected to all those external sources. Then the system function is it's okay, and that's all. So that's the capacity and that's the battery. Then this is 5 kilowatt, while each battery is 5 kilowatt as well, 5 kilowatt hour. So you can see, so this is the one. You can also increase this by putting another battery to make it 15 kilowatt hour. So it's also having its switches and connecting ports everywhere. As you can see the buttons for each battery. This is the power button. Each battery has its own communication port. So then this is the battery connection. This is the power button, and these are the dead switch. So this is the USB. All these are clearly labeled. This is the cooling fan. So the battery does not need cooling fan. It's the inverter that needs. That's why it's equipped with it. So you can see all the ports that are needed for it. So it's also easy to connect. It's easy to connect. The connecting ports are easy. At this part here, you can see the protective devices, which are the circuit breakers. You can see the outlets, which is plug and play, and then the terminals where you put your input cable, output cable, solar cables are there. So the installation is just easy and is fast. So that's that about the physical appearance and the way they function. Thank you very much.
Okay. Okay, thank you, Engineer Finley, for that wonderful live demonstration. So at this point in time, let's start attending to questions. Okay, let me start with some of us that raise our hands before I go back to the message box. So the first person here, Mr. Happiness or Happiness, please you can just see your questions now. Thank you, sir.
All right. Good morning. I hope you can hear me.
Good morning. Yes, I can hear you. Good morning, sir.
All right. So it's a very good system, perfect, portable, and handy. But I just want to raise a concern, which I want you also to address. My concern is especially with bigger size. What happens if the inverter is faulty? Because due to the weight of the battery, I'm sure the system will be very heavy. So when the inverter is faulty and we want to take it to a workshop, unlike the other one that you can easily pick up the inverter and take it to a workshop or to your office for repair, how do we deal with this situation like this where the inverter is faulty? Is the battery removable, or are we going to carry it as heavy to a workshop or to your office for repair? That's just my question.
Okay, thank you very much for the question. To avoid such a thing happening, I know that there is no system that is so perfect that one cannot say that cannot develop faults. Can happen even if you install 20 or 100, maybe 1 out of the 100 units give that problem, and then you now need to take it to a place. Well, first of all, one of the reasons why the batteries are divided, like the one that has 5 kilowatt hour now, to make it easily detachable so that you can carry it. Definitely, it has to go. That one now that has 5 kilowatts that you can detach, you can go with the with just one battery if the problem is with the system, or you go with only the inverter, to the for checkup to the office. But for the other one, you wouldn't have option than to go or call if the place is not far where one can check. We first of all check and see if it's something that can be done on site, because I understand that it's not that convenient to be carrying it all about. So if it's something that can be done on site, good. But if not, that it requires to be taken to the center, then it has to. So that's the answer to that. But where the advantage is that they don't easily fail. But I cannot say they cannot fail. No, they don't easily fail. We have installed many that we don't have the issues with. So that's the thing. Thank you.
Okay, thank you, Engineer Kunle. I hope you are clear on that, Mr. Happiness. Okay, he's not online. So
Yes,
the next is Ganiyu Abidemi. So the floor is yours. You can ask your question now. Thank you. Hello, Mr. Ganiyu, are you there? So if you are there, you can ask your question. Or
Yes,
okay, if he's not
yes, I'm
there,
here.
okay.
I'm here.
Okay, thank you. You can
Good
ask your
morning.
question now.
Good morning to everyone. And thank you, Engineer Kunle, for this presentation. It has been very insightful and informative. Now, quick one. I have two questions from my side. So the first one is, let us assume a situation whereby one of the components of this all-in-one, either the battery or the inverter goes bad. How easily, how easily can one get a replacement, I mean, from Genesis for either of these components when they go back earlier than expected? That is one. Now, second one, it has to do with the charging parameter. So, for example, in this presentation sheet, it is written charging current for AC, like maximum current. Now, that maximum current, what exactly is it speaking to? Is it speaking to the charging current from AC plus the charging current from DC, which is the solar PV, or is just speaking to one at a time? So those are the two questions that I want you to provide clarification.
Thank you very much for the questions. The first one is, how easy or how quick can you get any problem or challenges
No,
resolved?
replacement when either of the components go bad earlier than expected.
Okay. Replacement is because the batteries are available, the parts are available. It's not something that we need to go far to bring. They are available here. So it's easy to replace, and if it means replacing the battery, we do, so that we don't waste your time. If it has to do this is what I mean. If, for instance, it is the BMS, that's what fails in most lithium-ion batteries, and if that happens to fail, it's the BMS that will just be replaced. But if we are not finding it, maybe the BMS at that particular time is not available, which I don't expect, then the battery will be replaced for you. So far, it's still in good condition, as in the physical, not then is dropped Like I was talking with somebody, I think they dropped it from a vehicle and the thing just got dented badly. That's a different case. But if it's okay and just physically looking okay, then that one doesn't even waste. We don't waste time on that. We replace it immediately. That's on that replacement. But that's the BMS that cannot be resolved easily, or just to keep it going. It's still within the warranty. We don't joke with the warranty terms and conditions. That's that. Then on the charging current, there are two categories. I mentioned that one has a charging current stated. For instance, maybe one has 100 amps maximum from the inverter. That is the maximum the inverter can give. Then some were stated to be, okay, for solar, it's maybe 80 amps. And then for utility, maybe 80 amps. But the maximum is when you have the two, that's when the 100 amps comes to play. But for some, it is 100 amps for solar, it is 100 amps for utility, and the maximum is still 100. The maximum is what tells you the maximum current that can flow into the battery at any point in time from the inverter. That's the maximum capacity of the inverter in terms of charging. When you see maximum charging current from the inverter, that's what that means. But if you see solar charging current separately, maybe it's now lower. Maximum solar charging current is lower to a certain end. That means when it's charging with solar, it will give more than that value that is stated as its maximum charging current at that time. And then utility too may have its own maximum value when charging with utility. But the combined one, which is the maximum charging current of the inverter, is what goes into the battery. So and then when you cascade, that is what they are going to share. That's what they work with. So even the communication is still in progress, that when you cascade, they still communicate, they do everything, because it can be demanding for that maximum all the time, depending on how many batteries you have. If it's one battery, during communication, it may not demand for maximum current. You have just one system, one battery that is with it. It can just demand for 50 amps or 20 amps. The communication is normal. So it's the battery that will tell the inverter that, okay, give me this current. This is what I need at this point. So if it demands for the 100 as maximum, the inverter will give it to you. So far, the source is capable of giving that current, because you can't have a set of solar panels that cannot give more than 20 amps, and then the battery of the inverter is demanding for 100 amps. You don't get it anywhere if you are not using utility to charge, or you are not, if you cannot get the energy that is sufficient to push to the battery, it will only push what it can see, what is available. So that's the way it operates. I think I've answered the two questions. Thank you.
Yes, thank you so much. Well understood. I'm grateful, sir. Thank you.
Okay, thank you. Thank you, Engineer Kunle, for the answer. So next year is MI, me. So the floor is yours. You can ask your question, MI. Okay, I don't know if MI is there. So Mr. Bayo, first, please, you can ask your question as we wait for maybe MI. Thank you.
Okay, good morning. Thank you very much, Engineer Kunle. My name is Bayo Festus. So my question, I have two questions. The first one is this: for the lowest capacity solar generator there, which is 1.2 kilowatts, that's 1,200, the one with the 4 kilowatt hour battery. Yeah, I saw that the maximum PV input is 1,000 watts. 1,000 watts. Now, I went to Genex LinkedIn page, I think yesterday or so. So I saw a marketing video advertising or marketing that particular capacity. And the lady there was saying this particular solar generator comes with it will come along with 2 solar panels of 620 watts each as part of the total package given, I think, for about 1.1 something million or so. So my question is this: does that mean that it's going to accept more than that 1,000 watt PV input? Because if the lady is saying this goes with 2 panels of 620 watts each, that means you're going to have like 1,240 watts coming into it. So that's my first question. Then the second question is, with this all-in-one, is there any room for protection devices, breakers, SPDs? For example, the PV input breakers, or the SPD for the PV input, and also for the grid input breakers. Do we need to incorporate this, or the all-in-one system takes care of all this inbuilt? So those are my 2 questions.
Thank you very much for that question. Yeah, it's a bit technical, and I understand where you are coming from. For the capacity of the solar input, the MPPT, most of these products, let me say our product now. What I mean by our product is we know the way they operate. When I hear some people, they talk about some other products, they say, you cannot connect more than this capacity of solar panels to it, it's going to get damaged. For our products, you can connect more than the capacity of the solar panel. But this is what is going to happen. And this is the way you can achieve that. You can, so far, you did not go beyond the peak voltage or the maximum operating voltage of that MPPT. You are safe. For most of our products, you are safe, because I know some people said when they connected so number of panels in some units like that, it spoils. No, you can connect, like if they say it's a 1,000 watts and you want to connect 2,000 watts, in as much you are within the voltage range, you are within the voltage range, and you are advised to operate close to the maximum, but not operating at the maximum, so that it can be effective. The only thing that will be there is that the inverter, the MPPT, will not take more than its own capacity. That's just it. If the MPPT is 1,000 watts and you put 2,000 watt solar panel on the system, it will take more than its own capacity, which is 1,000 watts.
Okay.
So that's the thing. It's not going to get damaged, but to just process that one. So the advantage, where the advantage lies, is that early in the morning, if you can see, maybe by 7 a.m., you can see the 1,000 watt. It will process it and push it to the system.
Yeah, I got it.
So late in the evening but some people will categorize that as a waste of component. It depends on what you want to achieve. Because if you don't buffer it up a little, then when the weather is a little bit cloudy, then it goes down, and then your clients will be complaining.
Yeah,
so
that's a valid point.
Yeah. So in terms of the second question, can I remember?
Which is protective devices like SPDs.
Yeah, I understand. Now, it is always recommended with every appliance that is connected to external source. Your external source could be generator, it could be public supply, it could be solar panel. The manufacturer will put it in the manual that this is recommended. So if you want to have rest of mind and you want to just believe that, I'm much, much safer, then you put, I will call it double protection. It's not that there are no protections in the system. In terms of overload now, if you overload the system, it will shut down and come back on, sample it and see, is the load still there and all that. But if you don't want the inverter itself to experience any overload, which is a stress, anytime your inverter goes through all this kind of stress, is stress to them. If you don't want it to pass through all that stress, you can put circuit breakers at the output, put solar breaker to control the input if it's not having one on the body. But if it's having solar breaker on the body, you may not bother. And if you want to be able to monitor each string of your solar system, maybe instead of combining two together into a port, you want to separate it and you want to be able to control it. You want your troubleshooting to be easier. Then you can put circuit breakers separately before it gets to the inverter, so that string one, I know, oh, this is the string coming from the roof. I want to know, is it working? Your troubleshooting is easier for you. So all those SPD, they are also important because you are connecting to grid. You are connecting to solar panels that are mounted on the roof, and they are exposed to lightning. So you need to protect your system additionally. So they are important. It's not that because you have your system and it's protected, then it does all the protection. No.
Okay, thank you very much, sir.
You're welcome, sir.
Yeah.
Okay, thank you, sir, for that question, indirectly. So, okay, so we have let's attend to two more questions before we go back to our message box. So, I don't know if Mr. Mi or Emma is ready, but Mr. Kayode Anumo, so you can ask your question. The floor is yours. Okay, Mr. Said, please, you can ask your question. I don't think Mr. Kayode is available. Oh, oh, it's like no one available for now. So let's proceed to.
Okay, can you hear me now? I was muted before. All right, my question is
Okay,
still regarding
thank
what I
you.
asked on the chat box about the DOD for the SVC ESS. I asked two questions though. That what is the factory configured DOD, and also what is the DOD configurable? Which Engineer Kole answered yes, that it is configurable. But I want to know what is configured from the factory, whether it is 90%, whether it is 80%. I just want to have an idea. So that's my question. Thank you.
Okay, thank you. Most system by default, they give about 15 percent. Some give 10, some even give 5 of it, such that it will be 95% DOD. It will now leave the remaining 5 for to work. But I think this is about 80% DOD. This is about 80% DOD by default. And the reason is this. It will wake up by itself if it's not over discharged. Because nobody wants a system that it will shut down, and then because I don't have solar, when it shuts down, maybe it shuts down in the evening, then solar is not available, utility is not available, generator is not available, and it cannot sustain it till the next day. You know, the BMS, everything will still be running on the remaining percentage of the battery. So if it's not carefully done like that, then it may not wake up. I'm not saying that's exactly what's going to happen. If you leave a battery unused, naturally it will keep discharging, whether it has BMS or not. It's a natural thing. So how fast depends on the environment and the other things that is connected to it. If BMS is not connected to it, it will be very slow. So, and then how many batteries are connected in parallel? So if there are many, then the rate of discharge of the whole bank will be slow. So, but by default, I think it's about 80%. Thank you.
Okay, I hope you are satisfied with that. Okay, so let's quickly move to our inbox to attend to other messages or other questions. Okay, so the first question here says, with the high charging current bidding, it is advisable to parallel panels, sir, I repeat, with the high charging current given, is it advisable to parallel the panels, sir?
Okay. You can always parallel solar panels when it is needed. And one thing, like I mentioned to some as a answer or response to a question, in as much you did not exceed the voltage, then there shouldn't be any problem. But the inverter charge controller will not take more than its own maximum charging current. So if the maximum charging current, I mean the solar input current of the MPPT, which I explained and emphasized on, that is different from battery charging current. Battery charging current is the one that is always 100 amps, 120, 160. But for solar, it is always maybe 20 amps, 40 amps, or 30 something amps. It is within that current. So if it is 30 something amps or 40 amps, then, and you have a solar panel that is just 10 amps, you can parallel two. It will still give you 20 amps, which is not up to that. If your solar panel, the short circuit current is about 15, and the maximum current that the MPPT can take is still about 35, you can parallel two strings to give you 30 as 15 from each string of the panel, which is still under that. Even if it exceeds that 35 that is stated, the charge controller will not process the excess. It will only take the 30 that they are programmed that it can take. So that's the thing. I think that answers your question. Thank you.
Okay, thank you, sir. So the next question here says, what determines the charging current of the battery?
Okay, what determines the charging current of the battery is its level, because it's communicating. Once the battery is used, it will ask for charging current. Once the battery is used, it will ask for charging current. And when it's asking for charging current, the capacity of charging current it's demanding for depends on its communication with the BMS, with the inverter. So a battery may be discharging and the demand may just be 10 amps. I mentioned that before. But when it's very low, or when it discharges to a certain level, it sees that, oh, I can take 100 amps. It will request for 100 amps. If that 100 amps now is available from the source, maybe solar or utility or both of them, it will take it and push it to the battery. But if what is available that it can see is not more than 50 amps, it will accept it and still push it to the battery. Anytime it sees the maximum that is agreed between the inverter and the battery, he will take it and push it to the battery. So that's it. The moment battery is discharged, then the next thing that he wants to charge back. And that's what determines when battery will start charging and then the current it's going to request for. Thank you.
Okay, thank you, sir, for that question, for the answer. Okay, the next question, and I think this should be the last question. So it says, can the inverter on the system be upgraded or parallel, just like the battery can be upgraded?
Yes. I mentioned it's not all of them that you can upgrade or increase the battery capacity or increase the inverter size. But I emphasize on the 11 kilowatts, which is much more flexible. This one here is much more flexible because you can increase the battery, you can increase the inverter capacity as well. So each standing unit can be added to another standing unit, which means you have increased the storage, at the same time increase the load capacity that the system can power. So, and you can still increase the storage of each of them. So it's flexible. This one is flexible. So that's why I emphasize on it. Others that are also like that are flexible to a certain extent, we explain, like the other one, you can increase the battery from, you can start with 5 kilowatt hour battery, then you can increase up to 15 kilowatt hour battery. So that's also flexible, but you cannot parallel the inverter. You cannot increase the inverter capacity unless you want to do another separate unit, depending and divide your load. You can see if you still want to use that, okay, I've increased the battery, the storage of this one to 15 kilowatt, and I need another one. You can divide your load into two and still put it on another. They can run on different phases, but they cannot combine together to work as a synchronous 3-phase. If your system is 3-phase and you want to put that in each phase as a single phase, good, they work perfectly. Thank you.
Okay, thank you, sir. And I think we have come to the end of the program. And I want to also appreciate our facilitator, Engineer Kunle. Thank you for that awesome topic. And I also want to appreciate each and every one of us that are online. Thank you for joining. We value you and we love you. So for more information, visit our website or our shop, which is genestechnologies.com, www.genestechnologies, and you can also see the numbers there. You can call the numbers for to get our products, and we are expecting your calls and want to see you. Thank you. Thank you. God bless.